Alright, hopefully you've watched the first little one on vertical circles 1, vertical circles 2. Same situation, I just felt that we should split it up a little bit. We've got something going around in a circle like that. We've got the radius there, right? We've got a height here. We'll call that height, we'll call that R. We figured out that to get round at the top here, you needed, and for the centripetal force to be divided totally by your weight force, then you needed to have a velocity that was equal to the square root of GH. GR, sorry. Let's not get confused with our distances. GR. If it was bigger, it needed more than that, so it needed a bit of reaction force from the rails. But if it was less than that, it's going to fall. It's going to fall. It'll come around here, and if its speed's not quite enough, it's going to fall. So we just wanted to look at the energy situation in this. Now, if I ask you, this is just a little trick or a little a little trap that people fall into. So we got the potential energy from the top is equal to mgh, right? And we know we can convert that into kinetic energy at the bottom. And we know that that means that, what are we going to say? That means that the velocity equals the square root of 2gh. Now, if I now ask you for what velocity it will be doing at the top, calculate velocity at the top. What a lot of people do is they go, okay, let's have a look. If this is 30 meters, and let's say the radius is 7 meters, then that means this is 14 meters up here. And so they go, okay, so it was doing whatever speed it was doing at the bottom. Let's actually put numbers on this actually. So at the bottom, if it was 30 meters, then we can go 2gh. 2g, let's just use g equals 10. So that's 20 times 30, and we just take the square root. And we get 24.5. So v at the bottom was equal to 24.5 meters per second. And then what they do is they go, okay, now it's going 14 meters up, all right? So 14 meters up, we can just do the same thing. So if it goes 14 meters up, all right, and convert that, we can go half mv squared equals mgh, and they can do the same thing. So they go, okay, 14 meters, we'll just put it back in the formula there, and they go 20 times 14, they take the square root, and they get 16.7. So they go, it's 16.7, they must lose 16.7 meters per second, so they go 24.5 minus 16.7, and, hold on, my calculator suddenly stopped working. Okay, 24.5 minus, still not working. Alright, so anyway, they calculated 16.7, so we can easily do that. That's, let's have a look, 17 up to 24, 7.5, it's about 7.8, and they come up with that number. But it's totally wrong. And what you've got to actually do is realize that when the speed is dropping from, so at the bottom here, it was 24.5, as it drops down to whatever speed it's going to be, that's high energies. So if you go, say, between 24.5 and 16 meters per second, or 8.5 meters a second, the energy difference is 1/2 mass 24.5 squared minus 1/2 mass 16 squared, right? That's a big energy difference. It's not the same as just going the energy difference. It's not the same as 1/2 m times the difference between them, which would be 8.5 squared. That's the difference between 0 and 8.5, right? So you've actually got to do these little guys. You've got to remember not to fall into that trap. Hopefully you've seen what I'm saying, and I'll do it again just to make it more clearly. What you're basically saying when you do that is that, say I go from 0 meters per second up to 3 meters per second, right? What's the kinetic energy difference? Well, if my mass is, say, 5 or whatever it is, or 10. Say my mass is 10. Then half the mass times velocity squared, 10 times 3 squared is 9, that's 90, it's 45 joules. Alright, but what if I go between 3 and 6 meters per second? That's my change in velocity. I've still got a change in velocity of 3 meters a second, but you're going to see that when it was 3, we had 45 joules, but when it's 6, alright, we've now got the mass, which we said was 10, right? So 10 times 6 squared, 36, 360 divided by 2 is 180. 180 minus 45, right, comes out at 135 joules. So the change in energy to go from 0 to 3 is 45, from 3 to 6 is 135. So it depends where your change in velocity happens. From 0 to 3, there's a much smaller energy than from 3 to 6. So going back to our diagram, if you're changing from here to here, all right, then that energy difference, mgh, you can't just equate it going from 0 to whatever velocity and then subtract it off. So that's a very simple trap to fall into. How are we going to do the problem then, if that's what's happening to us? What we do is we just go, one thing we do know, and this is the easy way. So either we do it that way that I just said, which is we make the mgh equal to the final minus the initial, which would be half mv squared minus half mv squared. That's a change in kinetic energy must be equal to the gain in potential energy. Now the gain in potential energy is well, it's equal and opposite actually, but either which way. So this would be the 24.5 squared minus, and we'd be looking for the final one, right? That's going to be less, and that would be equal to the mgh, the h being the 2r times 2r, right? So if you like, do it like that, that's very nice and very careful, and you won't fall into that stupid mistake. But there's an easier way to do it, and that's this. Oh, another real crap circle. Let's get another bit of paper. The easy way to do this one is like this. And I've said, okay, at the bottom, so we've got the 30 meters. At the bottom, we've got the 24.5 meters per second. I've said that's 14 meters, or 2r. What's the speed at the top? The way to do it is just to go reverse the problem, if you like. The way to do it, oh god, I'm in the wrong place again. The way to do it is just go, well, if that's 14 meters, that must be 16 meters, right? And if that's 16 meters, then all we need to do is go, well, if that drops down, it's got a certain speed. And it's going to be the same as the speed for when that goes round and comes back to that same place. So this time we can actually do the mgh is equal to half mv squared. So we don't do the mgh for this height, we do the mgh for that height, and that will give us the correct velocity. So it becomes quite easy from that point of view. We can cancel the m's and we just go gh, the h is 30, 10 times 30, 300 equals half v squared. So that's 2 times 300, or 600, equals the square root of 600. And that will give you the velocity at the top. Common mistake, I've fallen into it on the odd time when I'm not thinking clearly. So vertical circles can be a little bit tricky. Watch that a couple of times if you didn't quite get it.